the Coders Campus podcast, where you'll learn how to code from one of the best teachers in the industry. Whether you're an absolute beginner or a seasoned pro, the Coders Campus podcast will teach you what you need to know to master the art of programming. And now, your host, Trevor Page.
Ladies and gentlemen, my fellow coders, welcome to this episode, which is, I believe, episode number 9, if I'm not mistaken. Yes, episode 9 of the Coders Campus podcast. Thank you so much for joining. Sorry about I had a bit of a break between this episode and episode 8. I've been hard at work doing that coding thing, if you will, hard at work with a new platform that I'm putting out. And, that's neither here nor there. I can talk about that maybe towards the end of this episode or maybe in a future episode. But I guess the main thing is what I promised was twofold. One is that I'm going to be doing lessons on Java 8. So Java 8 was released back in, I believe, 2014, and it's been one of the most quickly adopted versions of Java that have ever been released. There are a few reasons for that, and we'll get into those. But that is what I'm going to be focusing on for the next probably 2 or 3 episodes, is diving into some of the cool things that Java 8 has given us Java developers. The other thing that I promised was that I was going to be doing the draw for the 3 prizes for the review sort of contest that I was doing. So if you left a rating review and then emailed me that review, I took it, I put you into this contest. I have the names sitting and waiting for me to hit the random generator button to randomly select the top prize winner, as well as the second and third place winners. So I will do that at the end of this episode, just to keep you on your toes if you're one of the people who submitted a review. Wait till the end and you'll hear if you won. So, having said that, let's dive into exactly what I said I was going to talk about today, which was the Java 8 features. So really, like I said, this is the most quickly adopted Java version to date, people adopting version 8. So what is it that people are so excited about? Well, there's some sort of neat new toys, if you will, that we can play around with as Java programmers. One of these toys, if you will, are Lambda expressions. If you've researched anything about Java 8 and the hype about it and all the stuff, the reasons why people are using it, you likely have heard about Lambda expressions. If you don't know what they are, or if you tried to learn them and have sort of not really understood what they're for, hopefully that's where I can step in and break them down and make them as simple as possible for you to understand via this podcast. So, there you go. We're going to be talking about Lambda expressions today. I also really want to talk about streams. I'll probably be talking about that in the next episode. Streams are really cool, but they're really complex. There's a lot that you can do with them, and it sort of takes a shift in your mindset to understand how to use them. So that's a little teaser for the next episode. But for now, let's talk about the benefits of the Lambda expression. So from what I can tell from the research that I've been doing for the past, week or two on Lambda expressions, there's really only one big advantage to using the Lambda expression, and that is to have less code to write, and moreover, having a less verbose code base when you're, writing out your code. So I'll explain what I mean by that with an example. So let's consider the compare method. Okay, the compare method is used as a part of the comparator or comparator interface, depending on how you want to emphasize your vowels and whatnot. The comparator interface is typically used when you're sorting something, right? You do a collections.sort. Typically, you pass in a list, and then you pass in your comparator. Okay, so unless you're the object inside the list that you're using, so the object inside of your collection implements the comparable interface, then you need to also pass in a comparator. I apologize if I said that really quickly and you don't know what the heck I'm talking about, but just take my word for it. When you use a comparator to do sorting, this is a perfect example of what it is that where the Lambda expression really does shine. So we typically see the comparator used as what's called an anonymous inner class. Okay, and well, first of all, if you don't know, let me explain a bit what an anonymous inner class is. So break it down into the 2 different parts. First of all, anonymous. Okay, of the anonymous inner class. What does anonymous mean? Anonymous means there's no name given to the sort of method or the inner expression that you have going on here. So you see this a lot if you use JavaScript. A lot of the times when you create functions and passing functions around with callbacks, they're anonymous. You don't give a name to the function. With Java methods, If you create a method that has no name, just a method signature, that's an anonymous method, right? It's anonymous. Anonymous meaning there's no name. And moreover, the inner class part of it means it's a class that you are sort of declaring inside, sort of in line inside of your code that you have in front of you. So it's not creating a different class file and you're not creating a different class file and putting the code into a separate class file. We're embedding the code right inside, in line of whatever code we're dealing with, okay? Anonymous inner class. And these anonymous inner classes are notorious for a lot of noise, a lot of code noise, if you will. So I'll get into what it looks like to create an anonymous inner class with a comparator interface when we're doing a collections.sort right now. So let's say we have a list of transactions, for example. The transactions, maybe they have an ID and a date or something like that, and maybe more stuff that we don't care about, maybe an amount, maybe who knows, right? It's a transaction, right? It keeps track of perhaps a purchase or something like that. So the transaction, we have a list of them, and let's say that the transactions, we need to sort them by date, okay, by their date, because it's often important to have transactions sorted by date, sort of like on your credit card bill or whatever, right? You have a credit card bill, typically they're sorted by the transaction date. So how would you accomplish this feat to sort this list of transactions without Lambdas? So what does it look like, pre-Java 8? So let's say Java 7 or Java 6 or Java 5, because I believe we're able to do collections in Java 5 as well, or at least generics. So anyway, let's say we have a list of transactions that we get from a database somewhere. Okay, I don't care how we get it from a database, but we just have a list of transactions, and we want to sort that list. So we'll do a collections.sort to sort that list of transactions. Collections.sort, the sort method takes two parameters. The first is the actual collection itself, so the list of transactions. The second parameter it takes is a comparator. It wants you to pass in a comparator so that it knows how you want to sort these transactions, because there's obviously a bunch of different ways you can sort a transaction. You can sort them by ID, you can sort them by amount, you can sort them by date, etc., etc. So it wants you to, it's not going to guess, it wants you to tell it how to sort the transactions. So how you do that is you say collections.sort, you open your parentheses, you pass in transactions, which is your list of transactions, comma, so that was your first argument. The second parameter, is the comparator. So pre-Java 8, you'd have to pass in a comparator. So you would instantiate a new comparator. Okay, so you'd say new comparator, and the comparator, it uses generic, so it wants you to tell it what the object is that we're comparing on. So you'd pass in the generics section the less than symbol, greater than symbol, the chevrons I call them. Between the chevrons, you put in the object type, which is transaction. Okay, so new comparator, transaction. We're comparing transactions. You use your method open close whatchamacallit. Like if you're instantiating a new object, right? You always have to use the open parentheses, close parentheses. And then what you do is you have to create your anonymous inner class. So to create the anonymous inner class, you open up a curly bracket, and inside of it, and well, I guess you can close it too, but inside, between the scope of the open and closing curly brackets that we just created, you need to sort of implement the methods that the interface wants you to implement. So one of the methods that it wants you to implement is the compare method. Okay, so the comparator has a compare method that you must override. So you would need to put in that compare method into your anonymous inner class. So it wants a public int because it wants you to return int. It's called compare. That's the name of this method, is compare. Then it wants you to take or give it two parameters, transaction number 1 and transaction number 2, both having the type of transaction, because that's what we declared up when we created our new comparator. And then you needed to tell this compare method what to return. So it wants you to return an int. So the int that we're going to return is we're going to do T1, which is the first transaction in the list of parameters or arguments that we passed in. So T1.getDate, because we want to compare the two by their date. So we say T1.getDate.compareTo. Compare to will compare one object versus another and return an int. So you say .compare_to, and then you say t2.getDate. So you're doing t1.getDate.compare_to, t2.getDate. So you're just comparing the two dates of the two transactions. Okay? So one thing you may have noticed is that was a lot of talking that I just did. And what that talking represents is essentially, let's see, what looks like 7 lines of code, maybe 8 lines of code, to properly implement the collections.sort method when you create a new comparator via the anonymous inner class. Okay? So yeah, 7 or 8 lines of code. Annoying. Okay? Verbose, if you will. So that's without using lambdas. Now what does this look like with lambdas? Hopefully the less verbose part. Well, you start off the same way that we did before, which was we get a list of transactions from the database. Okay, again, I don't care how you get the transactions. Let's just assume that we have transactions and they're in list form. Now what we can do is we can say collections.sort, pass in our list of transactions, and then we implement our lambda function. So the lambda function uses an arrow syntax, which is the minus sign with the greater than symbol. Just like if you type an arrow out on your keyboard, that's how you type an arrow, right? So the lambda has an arrow. To the left of the arrow are the arguments. To the right of the arrow is the sort of the body of the expression that you want your code to actually implement. Okay, this is the code that you would implement when you're overriding that compare method, right? So to the left of the arrow, we have transaction T1, comma, transaction T2. You wrap those transaction T1, T2 in round brackets. We have put the arrow symbol, and then we put T1.getDate.compare_to T2.getDate. Done. That's it. A lot less code. Okay, so like I said, the lambda uses an arrow syntax. Well, I'll talk about that in a second. So there's a lot going on inside of that code, right? With less code comes a little bit less clarity in the sense that there's a lot going on under the covers, if you will, under the hood, than you realize. Okay, so when you sort of take away verbosity in the code, by definition or by default, there's going to be more going on under the hood that you don't realize, right? Unless you understand how it all works. So let me talk about what's actually going on under the hood. So, like I said, just to reiterate exactly how the lambda works. The lambda, as soon as you see an arrow, it's an arrow syntax. As soon as you see that minus sign with a greater than symbol, you know you're looking at a lambda expression here. Okay, it's the lambda syntax. So, again, arguments go on the left of the arrow, and the body goes on the right. Remember that the body of the code is the implementation of the method inside, of an interface. Okay, remember we had the comparator interface? I just had lunch, so apparently I'm a little bit burpy. I apologize. So, hey, this is a podcast that's recorded in more or less real time. This is what you get without post-production. I apparently can't afford post-production, so this is what you get. Anyway, so remember that we have a comparator. Comparator is an interface, right? The comparator interface, as defined by Java, has a method called compare. And the compare method is a method inside of an interface, right? So when you have a method inside of an interface, the method does not define any body, right? That is by definition a method's interface's method, right? It's kind of like an abstract method, right? There's no body to it. If you try to include the body of it, if you try to actually put real code, working code into the body of a method inside of an interface, you will get a compilation error. You are not allowed to do that, right? So that body, that implementation of the body of the code that I'm talking about, that is what goes on the right-hand side of the arrow syntax for the lambda expression. All right? And again, to the left of it are the arguments. Okay, so in our example that I was just talking about, the arguments are transaction T1 and transaction T2. Because think about the method that we are sort of implementing with the lambda expression. Okay, the method that we're implementing is the compare method, and if you were to write it out in full form, the compare method needs 2 arguments, transaction T1 and transaction T2. So we're just sort of extrapolating, we are abstracting the method signature away. We're taking just method signature out, plopping it into the left-hand side of the arrow syntax, the Lambda syntax. Then we're taking the body and we're abstracting it out and we're plopping it into the right-hand side of the Lambda syntax. So if you can visualize it that way, we're pulling the method signature out, putting it to the left. We're pulling the body out and putting it to the right. That's what's happening with this Lambda thing that we have going on. Okay? That's what is going on. That's the magic that's going on under the hood when you're executing the collections.sort method. Okay, remember the collections.sort, first parameter it takes is a list, essentially, that is to be sorted. The second argument is that it expects a comparator. Again, the comparator is an interface that defines one method that takes two templated parameters. Okay, in our case, the templated parameters are transaction T1 and transaction T2, but those could be anything. Those could be user U1 and user U2. That could be anything that you want to sort. Okay, there's probably infinite number of possibilities that can fit in there. That's why it's generic. They're templated parameters. You can put whatever you want in there. So this means that Java knows that you should be inserting a comparator as the second parameter of the collection.sort method. Okay, it knows that it wants a comparator in collections.sort, and it has some sort of idea of what method you could be implementing. Okay, when you're using the collections.sort and it wants a comparator, it has an idea of what method the comparator will be implementing, that you will be implementing, right? So then when you insert our two transaction arguments to the left of the Lambda syntax, Java knows that you must want to use the compare method. Okay, because there could be other methods inside of the comparator. That's the point I'm trying to drive at here. There could be other methods in the comparator, but as soon as you put in those two transaction arguments to the left-hand side of the Lambda syntax, Java will then understand that what you mean is you want to use the compare method. Because nowhere in our syntax, in the Lambda syntax, nowhere did we actually type the word compare. Right? Do you remember when I was saying it? We did collections.sort transactions, and then we put in brackets T1, T2 with transaction, T1, transaction T2 with a right-hand arrow, and then we said T1.getDate.compare2, not compare to, then we said T2.getDate. So nowhere in there did I say the word compare, and compare is the method that we are defining with some body of the Lambda code. The body goes to the right of the Lambda syntax. We're executing the compare method, but we didn't have to write that in, right? So I think of it like this. I think of it like method overloading. Okay, so if you don't know what method overloading is, when you have a bunch of methods that all share the exact same name, but they all have different method signatures, okay, Java knows which method to invoke based on the arguments that you pass into that method. Okay, so let's say, for example, you had a method called, get something. Okay, get something. So you have a method called getSomething, and in the parameter list, in the method signature, you're saying, string, S1. And then you have another method with the exact same name, getSomething. But in the parameter list, instead of passing another string, you're saying integer, I1. And then you have another method called getSomething, same name, and the parameter is, long, L1, and so on and so forth. All those method names are the same, but all of the method signatures are different. That's called method overloading. So the same sort of concept is happening here with the Lambda stuff. It's using the method signature to figure out which of the interfaces methods you'd like to invoke. Again, the interface is comparator. The method that it's figured out that we want to invoke is compare. Okay, so then, since this is an interface after all, there's no body in the interfaces method, in the compare method, so we need to actually give it some code, which is the code that appears to the right of the Lambda syntax. Again, I'm just repeating myself here. I'm saying the same thing over and over again in as many different ways as I can to really solidify in your brains what's going on. As I always love to say, if you're yelling at me and saying, I get it, Trevor, hurry up, move on, then that means I've done a good job and I should pat myself on the back. Okay, so now I want to talk about shortening that Lambda code that we were talking about, shortening it just a little bit more, which I know must seem like absolute madness to you because we've already shortened it quite a bit, right, with the Lambda syntax. So one more thing that you can do to sort of shorten your Lambda expression code is to remove the parameter types, okay, for the parameters to the left of the arrow syntax. So Java will actually be able to infer the data types in most cases, so long as, the sort of number of the number of method, or no, what are they called? Parameters. The number of parameters match as well as the parameter types match. Then it has no problem. If you have parameters that are the same number of parameters and the same type of parameters, then you need to obviously tell it what the heck is going on here. That might be the wrong way to say it, but let me explain what I mean here. So let's revisit the code that we had from before and let's remove the data types. So we were doing a collections.sort, right? We said collections.sort, we pass in our list of transactions, and then we need to pass in the comparator. But the comparator that we were using, we're passing it in as a Lambda syntax, a Lambda expression. To the left of the Lambda expression, we put our arguments, the parameters, right? So I said transaction T1, comma, transaction T2. What I'm saying here is we can omit the data type. We don't have to say transaction T1, transaction T2. We can just say T1, comma, T2. That's it. Cool, right? So even though T1 and T2, we've never actually declared those anywhere. Typically, if we were to use a variable like T1 or T2 somewhere, we would need to declare the data type and then the variable name. But the beauty here is that it can infer the variable's data type based on the method's signature of the interface that we are sort of what's the word? Lambda-ing? Is that a verb? Can I say lambda-ing? If I can't, then I'm coining that phrase right now. So we are lambda-ing the comparator interface, and it knows that since we have there's a method there called compare that takes two arguments and their transactions and whatnot. It can sort of figure out that this is what the data types of these T1 and T2 variables must be. They must be transactions based on what it has available to it, right? Beautiful. So, and I believe this is called, these are called functional interfaces. Typically, functional interfaces are interfaces that declare one method. Okay. Now when I read that makes perfect sense. If there's only one method in there, then of course, when you say T1, T2, and there's only one method, and that one method takes two parameters, then that makes perfect sense. It must be transaction T1 and transaction T2. But when I looked at the comparator interface, it has a whole boatload of methods. So that's what kind of confused me a little bit. I didn't really know how to attack that and how to explain that. Hopefully, if one of you guys knows exactly, or one of you girls knows what the heck is going on there, then by all means, leave a comment for me and explain this to me, because who knows, I might never figure this out, and I'm have to leave it up to you to tell me. You can go to coderscampus.com/9 to bring up the show notes, and you can leave a comment there. That'd be awesome. But from what I'm told, they're called functional interfaces. Functional interfaces are an interface that has one method, that it defines one method, and therefore that's the method. And it's easy to figure out that T1, T2 must point to that one compare method because there's only one. Okay, so that's just for your own little sake, for your tidbit, whatever the expression is. One little tidbit for your sake. There we go. Is functional interface. Interface defines one method. Is called a functional interface. Now, I think they used to be called SAMs, single abstract method. Okay. That was a sort of acronym, SAM. But I've never really heard of a SAM either, a single abstract method interface. In any case, there you go. This is the stuff that I learned. So that's a wrap for that. Wonderful. So you can shorten your Lambda expression to the left of the Lambda expression. You can shorten it by omitting the data type. Most times you can do that. Next thing that was kind of neat that Java 8 also released was a handy method called ForEach. Okay, for collections specifically. There is such a thing as a ForEach Loop. I've talked about it before, way back in probably the very first episode of my original podcast, the How to Program with Java podcast. I talked about the ForEach Loop. If you've been a coder for any stretch of time, maybe 6 months or more, you probably dealt with a ForEach Loop. The ForEach Loop is one where you say for. You open your parentheses, you put in a data type, you put in a variable name, you put in a colon, and then you put in a collection, a list or something like that, or a set or something that's iterable, that defines the iterable interface. When you do that, it will iterate through each of the items in that list, one at a time, and you can get access to them. So it's an easier way. It's sort of a less cumbersome way of defining a regular for loop, where you have to say, declare an index, into int I equals 0, I is less than, the collection dot size, I plus plus, all those things. You can type less stuff by doing a for each loop. Well, now once you've taken it one step further, you can do a for each method call instead of doing a for each loop. You can call a for each method on any collections that are iterable. Okay, and I say that because I think I tried to use a for each loop on a hash map, but it wouldn't work because the hash map that I used wasn't iterable. Okay, maybe a linked hash map is iterable, but regular old hash maps were not iterable. I forget the exact situation. Anyway, that's why I just wanted to put that little caveat in there. So, you can execute a for each method now, which is pretty cool. So let me talk about Lambdas in combination with for each. Let's say to output our list of transactions to the console. Okay, because that's something that we would do often. We would output the actual individual items in a collection to the console or to something, maybe onto the screen. Who knows, right? You're iterating through each of them, and you are outputting their values somewhere. Okay, so how would you do that with Lambdas and this new Java 8 for each method? So you do transactions, because remember, transactions is the collection. It's our list of transactions. So transactions dot for each. Okay, again, dot for each is new. Previously, we would say for transaction T colon transactions, right? We would do that, and then we'd say T equals blah, blah, blah. So, or T dot something to get access to the transactions that we're iterating through. But now we say transactions dot for each. Okay? And then inside of the brackets, we can say T, right arrow, so lambda arrow thing, system.out.println T. Done. Okay? Again, the arguments are to the left. The argument is T. The body is to the right. The body is system.out.println T. All right? So now, cool, fine, great. But this begs the question, well, what abstract method is the for each method working off of? Right? Because like I said, using lambdas are all about, implementing a method of an interface. Right? So if we're using a lambda inside of the dot for each, that implies that there must be an interface that has a method that we are implementing. So what is that interface, and what is that method that the for each loop is allowing us to sort of, lambda-ize? There's just so many words I'm making up here. So the for each method actually takes a consumer interface. Okay, the consumer interface defines generic type T. So consumer T, just like we have comparable T or comparator T, right? T is a templated type. You can almost substitute in the word object for T. Anyway, consumer T. The for each method takes a consumer T and it defines it. It calls it an action. Okay, that's the variable name that it uses for it, which is neither here nor there, but it calls it an action. That's the name of the parameter that the for each method takes. Okay, so having said that, the consumer interface has a method that takes a generic T object as a parameter. Okay, so the consumer interface, you can almost picture it. So if you were declaring if you were creating the code yourself for the consumer interface, it would be public interface consumer T, because it takes T as a template. And then inside the body of the interface, inside the scope of the interface, we have a method. Remember this SAM method, single abstract method, or the functional interface, if you will. It takes one method, and that method is accept, is what they've called the method. Again, the name of the method doesn't matter, because that's what we're abstracting away here with lambdas. We don't care about what the method's called. We don't have to type it in. We just have to know that there's a method there, and it takes an argument. The argument it takes is T. Okay, so it has a method called accept, and that accept method takes an argument called T of type T. So the variable name is T. It takes it of type T. T, of course, is generic. Substitute whatever type you want in there. Okay? So there you go. That's what we're doing here. We're saying transactions.forEach, and we are essentially, instead of saying new consumer, where we pass in a transaction, instead of having to say that, we're just saying T. Okay, because T here, the argument on the left-hand side of the Lambda expression, the argument represents the argument that's inside of the method inside of the consumer interface. Again, the method is called accept. We don't care what it's called, but the method's called accept. That method takes one argument, which is of type T, and it's called T. The variable type, or the variable name of the type is T. That's why we say T. Okay, I believe you could put any letter in there that you like for the name of the argument, because it's just you're substituting the name of the argument in your Lambda expression to the left of it, what have you. But T makes sense here because we're talking about transactions. So you put in T, Lambda symbol, and then you're putting in the body of the method. So the body of the accept method will be whatever you like. In here, we're using system.out.println, and we're outputting T as a transaction type. So if we were to make things a bit clearer, maybe you can rewrite this as the old version, so pre-Java 8. So if we were to rewrite this again, the ForEach loop pre-Java 8, again, the ForEach loop ForEach method wouldn't exist pre-Java 8, but let's pretend it would. It does. You can say transactions.forEach, and then we'd have to say new consumer. Okay, just like we did before with the comparator, we'd have to say new comparator. But here we're saying new consumer, because consumer is the interface. Consumer takes transaction, or T, as a type, so we put transaction as the type. And then you open close your parentheses, open your curly bracket, put in the override annotation for public void except. Okay, except is the method that the consumer interface defines. Except takes transaction T inside of its method signature. Then you declare the body of the accept method, which is system.out.println T, which is what we want to do. And then you close off all your open brackets and whatnot. Okay, so we're avoiding having to type all that out, and we're just using the Lambda expression to do everything that we need it to do. Pretty darn cool, right? I like it. It's a lot less typing, but the only thing is, like I said, it's a bit confusing if you can't for me, I'm all about visualization, right? If you can't visualize exactly what's happening with what we're pulling out of where and placing where to the left of the arrow and to the right of the arrow, if you can't visualize where those pieces are coming from, this is pretty confusing. But as soon as you can visualize it, as soon as you can say, okay, I get it. There's an interface. The interface declares a method. The method has a method signature. The method signature is what we're pulling out and putting to the left of the Lambda. And then whatever we would have put into the body of the overridden method of the interface, we're taking that out and putting it to the right of the Lambda sign, the arrow, if you will. Okay, so as soon as you can sort of think of that and realize that's exactly what's going on here, this becomes a whole lot easier. Now, there's more to Lambdas. There's more things that I can talk about with Lambdas, but it's already been over half an hour, and I obviously promised I would be talking about the the contest. So there's more to it, but that is the bulk of it. That is the 80%. 80% of the time you're dealing with Lambdas, you're going to be using them just in the way that I described. Okay, so pretty cool. Pretty cool stuff. Like I said, once you get your head wrapped around it, it's pretty easy. I'd highly recommend going to the show notes page to seeing the code, because if you can't really see the code, again, it's difficult to be able to visualize it through audio. Although a lot of people have said I do a good job at explaining coding through audio, so thank you very much. If you said that before, I take your compliment and I eat it up. But yeah, so hopefully go to the code coderscampus.com/9 to check out the examples and get a good idea of what it is that's going on here. And there's plenty of other great information all over the web right now about Java 8 stuff. I would highly recommend don't just stick to Coders Campus stuff. Go out there, research Lambdas through other people's websites. They do a wonderful job at explaining it too. But sometimes they miss little bits and pieces. That this is where I feel I can do a good job at explaining things and so on and so forth. So hopefully my explanation of the basics gives you the solid foundation you need to go out and play, if you will, by learning about it in other places as well. Cool? So, all right, let's call it the end of the lesson. Now I'm flipping over now, very exciting part, to the random name picker that I have created. I've pasted in all of the email addresses in here. So how do I want to do this? Do I want to say that the first name that I pick is the grand prize winner? Or I probably shouldn't. The typical North American way of doing it is you start with third place first to build up the anticipation to who the first prize winner is. So there you go. So what I have here is I have people's email addresses, and obviously I don't want to say the email address in its full extent, over the podcast, because I'm sure people wouldn't want me or consent to me giving away their email address. But what I'm going to do is I'm going to say sort of the people's either first names or last name. I'm pretty sure I know what all the first names are, but who knows? I will say the first name, and then what I'm going to do is I'm going to actually email you. So as soon as I'm done recording this, I'm going to email the people and let them know which prize they won. So if you did not get an email from me, but your name matches one of the names that I said, I apologize for getting your hopes up. So also look for an email from me. You'll be getting one from Trevor@craftycoder.com. So, all right, let's start with the third place winner. Again, third and second place win 2 months worth of membership to the Coders Campus platform, which is a platform I've actually been working on. Maybe I can draw this out even longer by talking about the platform that I'm building. I'm building this is why the past 2 episodes of the Coders Campus haven't come out when they should have. Normally I release on Fridays, and even this one's late. I usually release Friday morning. This is not coming out on Friday morning. Friday being August, 26th, 2016. So obviously if you're listening to this in the future, then that means nothing to you. But anyway, so yeah, normally I'd be getting these out on time, but this time I've been late because I've been busy working on an entire courseware platform. So if you're already inside the Coders Campus membership website, you have seen some tutorials where I show sort of the beginning of me building the courseware platform as a sort of webinar series. Okay. But since then, since I did the webinar series that Coders Campus members have been able to watch, I've been continuing to build this puppy out to the extent that it's built out now. And what it is like I said, it's a courseware platform. It's a platform where people who want to teach stuff, who have a course that they've built, can upload their course to my platform and distribute it to students. Whether it be a free course or a paid course, doesn't matter. They can go and either give away their course for free and get people to sign up for it, or they can, sell it and sell it to students. Right? So this is not a groundbreaking idea by any means. The part of it that is groundbreaking is I'm making it free. Okay, and the reason why I'm making it free is because I'm scratching my own itch. I looked high and low for a platform, just like the one I described to you, that is completely free, and it doesn't exist. There are some that are free, they say they're free to use, but they take a percentage of your sales. If you're selling a course, they take a percentage, sometimes upwards of 50%. Something like Udemy. If you've used udemy.com, if you put a course on udemy.com and make a sale, someone buys it, you immediately give away 50% of that sale to the platform, to the Udemy platform. 50%. That is an astronomically large number. And even some other platforms that are popular, some of them go as low as like 4 or 5 or 3 or 4 or 5%. But 3 or 4 or 5% of your sales, if you're making a lot of sales, is a boatload of money. Okay, I think of Shark Tank. I watch Shark Tank all the time, and when the sharks pitch someone and say, I want to buy your business, and I'll give you, you have to give me 2% royalty back or something like that. I'll give you $100,000 for a 2% royalty. People always say, "Ooh, 2%," and they hesitate about it, and they're like, "How about 0.25%?" So think about these platforms; they're taking 3, 4, 5%, and that's forever. So it's astronomically high. So I could not find one that was free. So I said, you know what? I'm going to build my own. And because I want to build my own for myself, I'm just going to release it for free to everyone else as well, because that's the kind of person that I like to be. It's someone who's helpful, right? So anyway, I've been building this platform and I have a deadline. I need to get it done in the next, it has to be done by September 1st, 2016. So it's currently August 26th. So I have 5 more days to get everything done. I'm very close, which is why I'm recording this now. I'm close enough that I'm confident enough that I can release a podcast episode and spend some time talking to you guys instead of programming. But anyway, that's why I've been backed up, and that's why I've been late with these episodes. Anyway, there we go. I burned enough time. Now I'm sure you guys are itching to find out who wins. So let's talk about that now. These will be the winners. We'll start with third place. They will get access to Coders Campus for 2 months, most likely on my new platform. Once the new platform gets up and running, hopefully around September 1st, they'll be on the new platform, which will be pretty exciting. So let's do the first name draw. Now, I should probably copy these email addresses just in case I lose them when I submit the name. So this will be the third place winner. I'm going to say pick a random name. Okay, so the third place winner, so they win 2 months of subscription access to Coders Campus. I'm just going to say Terry, and we'll say Terry uses a .co.uk email address. So if you are Terry who uses a .co.uk email address, I will be emailing you shortly with the good news that you won the 2-month membership to Coders Campus. So congratulations. So then let's remove Terry from the list, and let's move to the second place winner. Pick another random name. Okay, so I believe the name is pronounced Tafa, or it could be Tafa. I'm not sure. That could be a first name or a last name. Again, I'm not exactly sure, but I will be sending an email out to this person as well. So congratulations, you've won 2 months of membership to the Coders Campus platform. Again, I will be emailing you, so no worries. I will delete that person from the list. And here's the grand prize winner. So the grand prize winner also gets a 2-month membership and a $100 Amazon gift card that I will somehow, hopefully, be able to get to them. I live in Canada. If they're in the States, that's fine. If they don't live in the States, then it could be a bit complicated, but we'll figure something out. So here's the grand prize winner. I don't have a drum roll. I don't have time to unfortunately put in a drum roll, sound effects. I could do one myself, but that would just sound cheesy. So let's pretend there's a drum roll while I click on pick a random name. And there you go. So so I'm assuming the first name is not the name I see here. That looks like a last name. So I'm going to say the first name is Gary, is the grand prize winner. So if your name is Gary and you emailed in with your review, then congratulations, you've won the first prize. Again, I will be emailing you, Gary, with all the details, and I'm going to try to figure out where you live and figure out how I can send you that gift card as promised. So there you go. If you didn't hear your name, I'm so sorry, but hey, maybe if you didn't hear my name and you were really hoping for it, you can email me and maybe pull up my heartstrings somehow, and maybe we can work out a deal where you get maybe a month of access or something like that to Coders Campus, just because I like to be as nice as possible. I don't like disappointment, and I don't like to disappoint you guys. So email me if you didn't win and you really wanted to, and yeah, we'll see what we can do for you. All right? Awesome. Thanks so much for taking part. And for all of you who left ratings and reviews, I really, really appreciate it. It's really going to help to get this podcast out there and get it listened to by more people. And hey, even if you just, if you love the content and you want to support me, a great way to do it is to leave a rating review. So please do that. You can do it via coderscampus.com/iTunes, I think. That will should open up iTunes either on your computer or on your mobile phone. If you don't have iTunes installed on your computer, you're going to have to install it, unfortunately. I know, it sucks. I wish you could just leave a rating and review through the web somehow, but it has to be through the stupid iTunes platform. Sorry, iTunes, it is stupid, but I understand why they're making us do it that way. They want us to use their platform, so... Anyway, if you do install, I had someone who went and installed iTunes just to leave me a rating review. So I appreciate that so much. That means so much to me that you're willing to and able to go and spend that much time and effort just to leave a rating review. That is dedication. And if you did have to do that, leave that information in the review. That'll make me chuckle and make me feel good. So anyway. Thank you so much for listening. I look forward to seeing you guys in the next episode, where I'm probably going to be talking about streams. Streams are really, really cool, and they sort of revolutionize kind of the ForEach Loop, if you will. But that's about as much as I'll say for streams. But they're really, really cool stuff, and they're pretty complex. So I'll likely be talking about that in the next episode. So until then, take care of yourselves, happy learning, and bye for now.
Thanks for listening to this episode of the Coders Campus podcast. But before you go, Trevor has a favor to ask you. In order to keep these episodes free, he'd love for you to leave a rating and review the podcast on iTunes. Just go to coderscampus.com/review to leave your own rating and review of the show. So if you have 30 seconds to spare right now, please help out by leaving a rating and review via coderscampus.com/review. It will ensure that you continue to get these awesome free podcast episodes each and every week. So if you like free swag, head on over to coderscampus.com/review. Happy learning!